Every digital transaction, user registration, and data query on the modern web must eventually narrow down into a single bottleneck. Digital forms act as the primary gateway for user engagement. They are mechanisms that collect telemetry, secure user signups, and process revenue. Yet developers routinely treat them as a simple collection of basic HTML input tags arranged on a screen. A modern form is a highly sensitive full-stack micro-application. It handles user behavior, front-end validation, back-end routing, and database security simultaneously. To engineer these components correctly, we rely on the Royal Research Framework. This methodology builds high-performance forms from first principles. The Royal Research approach dictates three non-negotiable axes of development: streamlined user experience, strict accessibility, and uncompromising security. Transforming a fragile sequence of HTML tags into an enterprise-grade data pipeline requires layering these distinct operational architectures, one by one. The process begins at the absolute baseline, a bare, unstyled HTML form. At this stage, it possesses no logic, no visual hierarchy, and no guidance for the user. How we structure the visual layout directly dictates user completion rates. Grouping related fields together reduces visual clutter and provides an immediate sense of scale. We must also place explicit labels in immediate physical proximity to their respective inputs. This limits the eye movement required to parse the request, directly reducing cognitive load. Next, we apply JavaScript inline validation. This serves as our primary mechanism for real-time user feedback. Forcing a user to fill out an entire sequence, hit the Submit button, and wait for a server response to discover they missed a character creates immense friction. Real-time validation eliminates that wait. By capturing format errors instantly, users correct mistakes in milliseconds without breaking input momentum. The sole purpose of this UX layer is friction reduction. The interface ensures the user's path to data submission remains entirely unobstructed. Measured. A visually clear form means nothing if the underlying code is unreadable. We must engineer semantic integrity so the interface can be parsed by assistive technologies like screen readers. This diagram maps two DOM trees. On the left, generic div tags lack structure. On the right, semantic tags like field set provide explicit instructions. We then add area attributes, immediately tethering error messages to corresponding input fields to alert screen readers without visual searching. We must also guarantee a logical keyboard tab order. A structurally sound form can be navigated and completed entirely via keystrokes, completely removing the requirement for a mouse. For users with visual impairments, we verify that the typography is highly scalable and the color palette meets strict contrast ratios between the text and the background. Accessibility engineering transforms a rigid visual interface into an inclusive, navigable matrix, ensuring a wider total audience can interact with the gateway. This architecture map illustrates the dual validation paradigm, explicitly separating the client and server environments. Client-side validation is just a UX tool, allowing malicious code to slip past. Server-side validation is the uncompromising boundary, identifying and neutralizing hostile payloads before they reach the database. This requires strict back-end input sanitization. The server scrubs incoming data to prevent SQL injection, which manipulates database queries, and XSS, or cross-site scripting, which attempts to embed malicious scripts into the web page. This diagram shows the required transit protocol, HTTPS encryption. HTTPS scrambles the data traveling between the browser and server, making it unreadable. While in transit, it deflects external probes, preventing malicious actors from intercepting or tampering with user data. We then implement CAPTCHA protocols. A CAPTCHA is a challenge response test designed to distinguish humans from automated botnets, defending the gateway against mass submission attacks. On the server side, we apply rate limiting. This restricts the total volume of submissions permitted in a specific timeframe, neutralizing DOS, or denial of service tactics, designed to overwhelm the system. Finally, the gateway runs rigorous authentication checks, verifying identity before processing. An enterprise-grade form operates under a zero-trust model the millisecond data leaves the browser. Once the form is secure and accessible, we transition to the operational requirements for deploying and tracking it in a live production environment. We optimize front-end performance through lazy loading. This delays the initialization of non-visible form elements until the user scrolls down to them, drastically cutting the initial page render time. We also strictly minimize the use of external JavaScript libraries. Fewer external scripts means a lighter payload and faster parsing times for the browser. This funnel chart visualizes our drop-off telemetry and behavioral analytics, mapping exactly where users abandon the form based on field sequence. Identifying these friction points allows developers to continually iterate the design. Altering a single field requirement can noticeably increase total throughput. To manage these continuous updates, we rely on a CI/CD pipeline. CI/CD stands for Continuous Integration and Continuous Deployment, an operational method that automates the testing and delivery of code changes. This pipeline runs automated cross-browser testing with every code commit, catching rendering errors and logic failures before the update ever reaches the live server. Maintaining this complex system across a development team requires strict version control to track code changes, paired with exhaustive technical documentation of the form structure. A form only reaches production readiness when its deployment, ongoing testing, and behavioral telemetry operate completely automatically. Look closely at the final implementation. It functions as a fully integrated, multi-layered data architecture. The UX layer systematically removes input friction at the point of contact. The accessibility layer ensures structural inclusivity, ensuring assistive technologies can parse the environment. The security layer enforces data integrity, blocking malicious exploits via strict server-side logic and encrypted transit. And the production pipeline guarantees scalability, accurate telemetry, and entirely reliable deployment. This is the core philosophy of the Royal Research Standard. We mathematically optimize the entry path for legitimate users, while simultaneously locking out hostile payloads. Developers must abandon the practice of building fragile HTML inputs. The web requires robust, secure, enterprise-grade data gateways.